exciting to come your way once again. My name is Nana Ewedu. You can call me Nana. In our previous lesson, we have considered some special types of triangle, which includes the equilateral triangle, the right triangle, the isosceles triangle, acute triangle, obtuse triangle, and scalene triangle. Remember to like this video, share this video, subscribe to my YouTube channel, comment at the comment section if you find anything interesting or you want to ask any question. And don't forget to click on the notification bell so that you can be abreast with all videos that I put out here. In this lesson, we want to consider the exterior angle of a triangle. I will be able to prove the exterior angle so that we'll be able to have a good understanding of what the exterior angle is. So let's consider this image. So basically, when we look at this image, we are seeing a triangle. Let's consider the size as A, B, and C, right? So when we talk about the exterior angle, we are just looking at an extension of the triangle. The angle formed when there is an extension of the triangle. So the angle formed here, if we call it E, is the exterior angle. Or the angle that can be formed here, we can call it, let's say, M, is the exterior angle. Or the angle that is formed on the extension here, when we call it P, will be the exterior angle. So for instance, when we consider the E, the theorem says that the opposite, the direct opposite of the exterior angle, which is the A plus the B, should be equal to the E, which is the exterior angle. So the angles on the opposite, which is A and B, should be equal to the exterior angle E here, right? So you ask yourself, why are they saying this? Why is it that they are saying that when we sum the opposite interior angles, which is A and B, we should get the exterior angle, which is E? Now let's look at that very quickly. So we want to look at the Y. So we want to prove the exterior angle theorem. So basically we know that a triangle sum up to 180 degrees, right? We say that a triangle sum up to 180 degrees. So for instance, if you have A plus B plus C, that should be equal to 180 degrees. Now let's express this in terms of C. So we can see that if we want to express it in terms of C, then our C should be equal to 180 degrees minus bracket A plus B, right? So we are moving the A and B to the other side because we want to make C the subject. Now we know that the exterior angle of a triangle, when we are considering E, should be equal to A plus B, because we say that the exterior angle is equal to the sum of the opposite interior angles, so A and B, right? So E should be equal to A plus B. So we've established that. Now, we can see that A plus B, let's call this equation 1. Now, let's say that C to be equal to 180 degrees minus into bracket A plus B will be equation 2. Now, because we know E to be equal to A plus B, we can do a substitution. So we can say that put equation 1 into equation 2. So we want to put the value of A plus B, which is E, into equation 2. So that implies that we can have our C to be equal to 180 degrees minus E, right? Where we know that our E is A plus B. Now here, let's make E the subject because we want to find E in terms of A and B. So we see that our E should be equal to, when we move our E to the other side, it becomes positive. So we are 180 minus C, right? So we know that our C is what we have here. So let's call the equation here equation 3, right? So now we want to put equation 3 into the equation here. Let's call this equation 4. So we'll put it into equation 4. So it means that we have our E to be equal to 180 minus wherever we see C, we want to put the value of C here, there, right? So that should be equal to 180 again. Let's put this into brackets, minus A plus B, this into brackets, right? So this implies that our A should be equal to 180 minus 180, which cancel out, and it implies that our E should be equal to A plus B, because this minus and this minus will give us positive. So it means that we've gotten our proof for our exterior angle. E is equal to A plus B. So we can say that hence proved. So we've been able to prove it, right? So by algebra, we've been able to go through the process. We've added the three interior angles, equate them to 180. We've gone through the process to be able to prove that indeed, if you have the exterior angle, is equal to the opposite or the sum of the opposite interior angles. Now let's consider how we can also prove this when we are looking at it in terms of geometry, in terms of the diagram, how it looks like. So in the diagram here, we see a triangle first and foremost, and the triangle is triangle A, B, and C, right? And then it has been extended from C to D so that we can have the exterior angle here, which consists of, so the exterior angle is x plus y, right? It's equal to x plus y, so which is here. Now we've extended the C to E, right, such that we create two parallel lines. So CE is parallel to BA, right? So we see two parallel lines. So once we have two parallel lines, remember that we mentioned some rules or some angles that can be created, special angles that can be created when we have two parallel lines. So we can extend these lines so that we can see them well, right? So we can see the alternate angle, or what we call the Z angle. So we have an angle at A here. We can see that it is alternate to the angle X. So we can say angle A is equal to angle X. Or we can say angle B to A to C, right, is equal to angle A to C to E, right? And then it means that A is equal to X. So that is for this side. Now we also see that our Y is equal to our B. So A is equal to X because they are alternate angles, right? So they are alternate angles, as we learned earlier. And then Y is equal to B because they are corresponding angles. So the angle on the outside is equal to the angle on the inside here. So they are corresponding angles, right? So we see that when we want to write it in terms of angle, we can say that angle ABC is equal to angle DC and E, right? So that implies that if you want to find our Y plus S or X plus Y, it should be equal to A plus B. Based on what we've looked at over here, if you want to find our X plus Y, which is the exterior angle here, right? Let me use the pencil here. So the exterior angle here, which is X plus Y, based on what we've looked at, we've seen that X is equal to A because they are alternate, and then Y is equal to B. So X plus Y, which is the exterior angle here, is equal to A plus B, which is the interior angle there. Hence, we can say that we have proved that, right? Hence, proved, right? So we have proved that the exterior angle, right? So we've proved that the exterior angle, let me clean and write it well. So we proved that the exterior angle is equal to the opposite interior angles, right? So basically in this lesson, we've gone through the process where we have been able to prove that the exterior angle is equal to the sum of the two opposite interior angles. We've looked at it geometrically where we've seen the triangle, we've used the parallel sides to be able to determine that. We've looked at it where we are using algebra to be able to determine that once we have the sum of the interior angles of a triangle to be 180, we should be able to prove that the exterior angle is equal to the sum of the two opposite interior angles. In our next lesson, we want to solve some questions on these exterior angles. Remember to share this video, like this video, and subscribe to my YouTube channel. See you in the next lesson.